Okay, this video gives you hints for station number 4, the lottery. The first hint I want to give you is for problems 4 and 5. You're basically just using combinations. Number 5 is a little different from number 4 in that you are selecting 4 correct numbers from the 5 correct numbers, but you're also selecting one incorrect number from the 51 incorrect numbers. So you want to keep that in mind when you're computing the probability for number 5. Number 6 uses a term called a random variable x. Number 6 is basically asking you to complete this table that I have listed here for number 6, where x represents the number of matched numbers. So if you pick 5 numbers, and again, we're not including the mega ball in this, we're giving no consideration for the mega ball for number 6. So 0, the row that has a 0 in the x column, refers to not matching any of the 5 mega balls. So the question is, what's the probability of not matching any? And then 1 is what the row 1 is saying, what's the probability of matching 1, and so forth. When you get to 5, when you get to 4 rather, you've already computed the probability of matching 4 numbers. In question number 5. So your answer to question number 5 will just go in that row. Question number 7 is just asking what's the probability of matching the mega ball. Pay attention to the fact that there's a single mega ball numbered 1 to 46, and the person playing the lottery just needs to match that one mega ball. What's the probability of that? Realizing that the numbers 1 to 46 each have an equally likely chance of being selected. Number 8, you have to take into consideration, so you have to redo what you did in number 6, except this time you have to take into consideration the mega ball, and the mega ball changes the sample space in the way that I've shown here. That is that instead of just having 6 outcomes, you now have 12 outcomes, because you could match 0 of the 5 numbers, or you could match 0 of the 5 numbers and match the mega ball. You can match 1 of the 5 numbers, or you can match 1 of the 5 numbers plus match the mega ball. So that changes the probability. It changes the denominator that you used in number 6 because you have more possibilities. That's a very big hint right there. This third column that I've listed here for number 8, you actually don't need it for number 8, you need it for number 9. So let's go down to number 9. For number 9, you need to compute the expected value. And to compute the expected value is exactly what the name implies, is the value you would expect to get if you played the lottery over a long period of time. You can actually compute this value. The expected value is the same as really the mean. So you'd use the third column in number 8 for what we're calling the gain of X. That's the net amount that you would receive. So you pay $1 for your ticket, and then if you won, you would receive whatever the prize amount is. So you have to include the fact that you actually had to pay $1. So if your prize amount was $7, but you paid $1, your gain of X would be $6. Please refer to example 7 on textbook page 196 for help with this concept, because once you compute the gain of X for each one of the possible outcomes from problem number 8, then you'll need to calculate the expected value, and there's a very clear description, easy to follow, step-by-step process for computing the expected value. Finally, in order to compute the expected value, what I have at the bottom here is the payout from the Virginia State Lottery. Notice that all of the outcomes from playing the lottery are not listed in the payout. That's because there are sometimes when you play where you win nothing. So if you don't see a value listed here, that means that the payout for that match is 0. For example, you'll notice that matching one ball and not matching the mega ball isn't listed here. That means that the payout for that would be 0. Finally, the payout would be 0. So you need to figure out what would the gain of X be, considering that the payout is 0 for that. In addition, the mega ball, just matching the one mega ball, actually gives you a payout of $2. Okay, hopefully this clarifies station number 4 for you. This document is also in Edmodo if you want to use it to help you think through and work through the probabilities that you're asked to